Okay, guys, I guess everyone is here. So let's get started without any further ado. One last time confirmation though. I hope everyone can hear me. Rohit, Shekhar, Zion. I hope I'm pronouncing that right. Zion or Zion? What is that? Anyways, right. So let's get started, guys. In today's class, as I've mentioned earlier, we will be talking about networking concepts, the first prerequisite required for cybersecurity. We'll discuss about IPv4 addresses today, basics of IPv4. Okay. Now, before we get into these, the technical concepts of IPv4, let's talk about two important definitions. What is a host and what is a network? So when you talk about a host, guys, any information device which is capable of communicating with other devices or sending data and receiving data from other devices is called as a host. As an example, your mobile phone, your router, your laptop, your smart TV, okay, your you could say a tab or iPad, whatever it is, any of these devices which is capable of sending data to other systems and receiving data from other systems is called as a host. And when you have a collection of hosts communicating with one another, sending data to each other, that is called as a network. So a network is a group of hosts which can send data to each other. Now, just like how we can communicate with one another with our names, I can call you respectively by your name, and you can call me back by mine. Similarly, devices have their own unique names as well, and that name is called as an IP address, okay, which stands for Internet Protocol Address. This was developed by the US military in the late 1950s or so. There was IP version 1, IP version 2, and IP version 3. They were quite experimental. Okay, they didn't work out properly. What successfully worked out was IP version 4. And even in today's world, we are still using IPv4 addresses. Okay, and this IPv4 addresses has a few properties to it. It's firstly a 32-bit address. What I mean by 32-bit address is that it contains 32 zeros and ones consecutively. A bit is the smallest data format in computers or in any information device. It is either equal to the value of 0 or equal to the value of 1. And your IPv4 address consists of 32 zeros and ones consecutively. Now, this 32-bit address again is divided in 4 equal parts, where each part consists of 8 bits, and that is called as an octet or a byte. And each octet or byte is divided by a dot symbol. So this is what your typical IPv4 address looks like in the binary format, or in the language of zeros and ones. So that language of zeros and ones which computers understand easily is called binary language. But we humans don't understand binary so well. Okay, what we usually understand are decimal numbers, numbers from 0 to 9, right? So today we learn how do we convert any binary number to a human readable decimal number. Okay, before that, a quick data size recap. Okay, so 1 bit is equal to 0 or 1. When you combine 8 such bits, that becomes a byte, or it can also be called as an octet. Then 1024 bytes becomes a kilobyte, KB. This notepad file that you observe here is usually in kilobytes of storage. 1024 kilobytes becomes a megabyte. Your images, your pictures, your audio files are usually in megabytes of storage. 1024 megabytes becomes a gigabyte. Movies, okay, or larger videos or applications are in gigabytes of storage. 1024 gigabytes becomes a terabyte. Your hard drive storage, the complete hard drive might be in terabytes, right? And 1024 terabytes becomes a petabyte. We might not come across petabytes in our regular life, but again, these are used by cloud organizations. So again, cloud organizations which store the data of millions of users, such as Google Cloud, OneDrive, Dropbox, okay, all these cloud organizations have petabytes of storage. Okay, again, guys, if anyone has any questions or if you don't understand something, or if I'm going too fast, please do let me know. Okay, so that I can again repeat if you have not understood something and explain it in a much better way. Okay. So any questions or doubts up to this point? Again, what are IPv4 addresses? What are the properties of IPv4 addresses? And what are the different data sizes? Any questions? Brijesh, Rohit, Shekhar, Zion? Right. Now, let's talk about how do we convert a binary number to a human readable decimal number. So let's take this octet here. 10101010, this number. Okay, so that's the same number which I've written down over here actually in an expanded format. 10101010. Now there are two simple rules to convert any binary number to a human readable decimal number. Rule number 1 is we need to write down the values from 2 power 0 to 2 to the power 7 from right to left under each bit. So rightmost bit will have 2 power 0 under it, then you have 2 power 1, then you have 2 power 2, then 2 power 3, 2 power 4, 2 power 5, 2 power 6, and 2 power 7. From right to left under each bit, you are writing each of these values. You might have a question, why specifically 2 power? Because this is a binary number, guys. In binary, you only have two possibilities, either 0 or 1. Okay. And once you've written down those values, guys, to convert this to a decimal number, you just multiply the lower number with the top one and keep on adding with the next one. Okay. So 2 power 0 into 0, then plus, let me write a plus here, plus 2 power 1 into 1, plus 2 power 2 into 0, plus 2 power 3 into 1, plus 2 power 4 into 0, plus 2 power 5 into 1, plus 2 power 6 into 0, plus 2 power 7 into 1. So all you're doing is you're multiplying the lower number with the top one and adding on to the last value. So let's note down the values for each of these 2 power values. 2 power 0 is anything to the power 0 is always equal to 1. It's a mathematical rule. 2 power 1 is 2 itself. 2 power 2 is 2 into 2, that's 4. 2 power 3, 2 into 2 into 2, that's 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. Right? So if you multiply these values now, 2 power 0 into 0, that's 0 itself. 2 power 1 into 1, 2 power 1 is 2. Into 1, that's 2. 2 power 2 into 0, that's 0. 2 power 3 into 1, that's 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0. 2 power 7 into 1, that's 128. And if you add all this up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we read the number 170 as 170, the computer understands it as 10101010. So in the computer's language, it understands it in this way. And we humans read it as this number. Okay. Is that clear, guys? Now, if you have understood this concept, I have a number here, all ones, 11111111. Can you calculate this and give me the the decimal value for it? All ones. If you have a pen and a paper beside you, you can take your time and let me know the actual value for it. Okay, I've got one answer already. Correct answer actually, Brijesh. Let's wait for the others to complete as well. Again, guys, all you have to do is multiply the lower number with the top one and keep on adding with the next one. And I've written the values for each of those numbers here. Take your time, no rush. Calculate this or convert this to a decimal number and give me the answer. Rohit, Keker, and Zayan. Please do not hesitate to let me know if you have not understood, guys. I can explain again. And again, when I was learning this for the first time, it took me at least 1 day to understand this whole concept. So if you're learning this in the first 15 minutes itself, you're doing more than great. So again, if it is complex, if it is too complicated to understand, do let me know. Any answers, guys? Rohit and Shekhar. All ones. 11111111. When you convert that from binary to decimal, what would the answer be for that? Shekhar, that might not be the correct answer. Again, you have to add all the values, Shekhar. 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 plus 2 power 3 into 1 plus 2 power 4 into 1 plus 2 power 5 into 1 plus 2 power 6 into 1 plus 2 power 7 into 1. So everywhere you would have into 1, you're adding all of them. So it would be 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. So definitely it would not be the answer which you have given me. Is that clear, Shekhar? Where you might have gone wrong? Okay, guys. So let me give the answer away. It's 255 actually. So as I've mentioned, all you have to do is multiply the lower number with the top one, right? So 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 plus 2 power 3 into 1 plus 2 power 4 into 1 plus 2 power 5 into 1 plus 2 power 6 into 1 plus 2 power 7 into 1. 2 power 0 is 1. So 1 into 1, that's 1. 2 power 1 is 2. 2 into 1, 2. 2 power 2 is 4. 4 into 1, that's 4. Oh, let me sort it out. Yeah. 2 power 3 is 8. 8 into 1, that's 8 itself. 2 power 4 into 1, that's 16. 2 power 5 into 1, 32. 2 power 6 into 1, 64. And 2 power 7 into 1, 128. And if you add all this up, 128 plus 64, that would give you how much? 192, I guess. 192 plus 32, 224. 224 plus 16, 240. 240 plus 8, 248. 248 plus 4, 252. 252 plus 2, 254. 254 plus 1, 255. So when you put all ones, the maximum number you would get is 255, right? Is that clear? Shekhar, Rohit, I hope you have understood what the error was. Brijesh, you have given the correct answer.
Yes.
Right. So again, the reason I'm explaining you this range, guys, I mean the conversion, is to understand the range of IP addresses. In a real-time scenario, you might not have this necessity, but at least now you will logically understand what is the first IP and what is the last IP. So if you had to get the first IP, the minimum value you would put is just all zeros every bit. So in the first 8 bits, all zeros, second octet zeros, third octet zeros, fourth octet zeros. When you put all zeros, and when you convert that from binary to decimal, you would just get the value 0.0.0.0. And that would be your first IP address. And if you want to get last IP, just put all ones. That's the other possibility. And when you put all ones, you would get the last IP as 255.255.255.255. So now you logically know whatever IPv4 addresses are there, they will only range from number 0 to 255. You will never have an IP address above the number 255. The reason being, when you convert all the 8 bits in every octet, the maximum number you can get is 255 only, not more than that. So you will never see an IP like 300.256.400.10. This is an invalid IP. It's incorrect. Okay. A valid IP will always have numbers between 0 and 255. So a number like an IP like 192.168.0.2, this is a valid IP. Okay, and this is an invalid IP. I hope this is clear. Shekhar, Brijesh, Rohit.
Yes.
Now we know the first IP, we know the last IP. What about the IPs in between? How do we understand the sequence of IPs? So to understand the sequence of IPs, again, 2 simple rules. Okay, so coincidentally, everything has 2 rules. So again, rule number 1, always start with the rightmost value. So what I mean by that is, if this is our first IP, 0000, the next IP would be 0001. So the rightmost value will increment by 1. So always start with the rightmost value, increment the value by 1. Increment in the sense added by 1. Okay. So after 0, you have 1, then 02, then 03, then 04, then 05, then 06. Goes on all the way up to 0255. After that, you cannot have a value like 000256. This is not possible. It's an invalid IP. So once you reach the maximum number, then comes rule number 2. Only after the rightmost octet has been completely filled, then you go to the left value, okay, and reset the rightmost values back to 0. So this left number, the 0 now, left side of the rightmost octet increases by 1, and the 255 cycles back to 0 again. Okay, it gets reset back to 0. So now after 10 now, don't directly jump to 0020. That is wrong. Remember rule number 1, always increase the rightmost value first. So whatever cycle repeated from 00 to 0255, same cycle repeats again now from 10 to 1255. So 10, 11, 12, 13, 14, 15 up to 1255. Then again 255 here. So this 1 now changes to 2. And 255 cycles back to 0. So then you have 20, 21, 22, 23, 24, 25, 26, 27 goes up to 2, 255. Then 30, 31, 32, 33, 34, 35 goes up to 3255. Then 40, 41, 42, 43, 44, 45, okay, goes up to 4255. Okay. Then 50, 51, 52, 53 up to 5255. Like that, the cycle keeps on repeating again and again. And somewhere down the line, you'll have 2550, 2551, 2552, 2553, 2554, up to 255, 255. Now both these octets are filled. Now once they are filled, the next value 0 changes to 1 here, and these two 255 cycle back to zeros again. So whatever repeated now from 0, 0, 0 to 0, 255, 255, same repeats again from 1, 0, 0 to 1, 255, 255. So again you have 0, 0, then 0, 1, 0, 2, 0, 3, 0, 4, 0, 5 up to 0, 255. Then 1, 0, 1, 1, 1, 2, 1, 3 up to 1, 255. 2, 0, 2, 1, 2, 2, 2, 3 up to 2, 255. So this whole cycle, whatever repeated from 0, 0, 0 to 0, 255, 255, same cycle repeats again from 1, 0, 0 to 1, 255, 255. Again from 2, 0, 0 to 2, 255, 255. 3, 0, 0 to 3, 255, 255. 4, 0, 0 to 4, 255, 255. 5, 0, 0 to 5, 255, 255. And so on, it'll go up to 25500 to 255, 255, 255. All these three octets are filled now. So this last 0 now increments by 1. So this becomes 1 and these become zeros again. Now whatever cycle repeated up to here from 0, 0, 0, 0 to 0, 255, 255, 255, same cycle repeats from 1, 0, 0, 0 to 1, 255, 255, 255, from here to here. Then from 2000 to 2255, 255, 255. From 3000 to 3255, 255, 255. From 4000 to 4255, 255, 255. Again 5000 to 5255, 255, 255. 6000 to 6255, 255, 255. And finally 255000 to 255, 255, 255, 255. This is the last IP here. So this was the first IP and this was the last IP. And if you had to calculate the total number of IPs now, each octet, guys, is revolving 255 times and you have 4 octets. So the total number of IP addresses you would have is 255 into 255 into 255 into 255. And that would give you 4.3 billion IP addresses. So in the last 5 minutes from the first IP to the last IP, we actually tried to count all the 4.3 billion IPs. Okay, again, roughly. Okay, so again, if I were to ask you a question now, are these 4.3 billion IPs sufficient in today's world? What would your answer be for that? So from the first IP till the last IP, we have approximately 4.3 billion IPs. Are these sufficient for us today? Any answers, guys? Brijesh, Rohit, Shekhar, Zayan. Are these 4.3 billion IPs sufficient for us today? Definitely not. Right. So yeah, Brijesh has given the answer no. Again, if you actually know the population today, it's around 8 billion people. We have crossed the 8 billion mark, right? And again, each person might have multiple devices again. So I myself at my home might have a router, might have a laptop, might have a smartphone, and 3 devices there itself. Okay. So there are 8 billion people and each person has on average 2 devices at least. You still need 16 billion IPs, but we only have 4.3 billion IPs here, right? So how did they overcome this problem? So they tried to overcome it in 2 solutions. Solution number 1 was dividing these 4.3 billion IPs into 2 categories called public and private IPs. Okay, so this solution was called as NAT, Network Address Translation, where some IPs were called as public IPs or unique IPs and some IPs were called as private IPs, which could be used in local networks. and they could be repeated multiple times. Okay, let me elaborate on this a bit more with a diagram. What do I mean by public and private IPs? So let's assume, let me just quickly draw a diagram here, guys. Just give me a minute. Yeah. So let's assume here this is our home's Wi-Fi router. So usually we have a Wi-Fi router at our home. Let's call this as R, which denotes a router. And to this router, we have our internal devices connected. My laptop, my smartphone, my smartwatch, okay, my smart TV, whatever devices exist. Okay, these are connected to the router wirely, with a wired connection or a wireless connection. Okay. So I have a connection here from each of these devices to the router. Now your router, guys, which is located at your home, will also have a connection coming from outside your home. Okay, so to the router, you'll have a cable, an optical fiber cable or a RJ45 cable coming from outside the house, and that cable comes from something called the ISP. Okay, so let me change the color for that. So this ISP, which stands for Internet Service Provider. In India, we have ISPs like Airtel or Hibernate, Pathway. All these are the ISPs in India, and these people provide you the connection of internet, and that happens with something called a public IP. So public IPs are present with your ISPs, guys, and they provide you a public IP to access the internet. So this outer region is called the internet, and your internal, this network, your local network, is called the intranet. Okay, your local home network, and in the intranet, each device gets a private IP. So your router also gets a private IP. It's called, let's assume it's called as something like private IP1, PR1, and your laptop might get PR2. Your phone could get PR3. Your smartwatch could get PR4, and your smart TV could get PR5. Okay, private IP5. So whenever each of these devices wants to communicate with the internet, if you're visiting a website like google.com here, let's say, okay, https://google.com. So if you open up your browser and your phone and you're accessing google.com, this Google has a public IP to itself. Okay, something like public IP X, let's say. Okay, something like 1.2.3.4. 1.2.3.4. So what happens is, first from your phone, the connection comes to your router. So from your phone, a connection comes to the router first. From the router, let me change the color for that, just in case if it's confusing. Yeah. So from the phone, the connection comes to the router first, from private IP3 to private IP1. From the router, the packet now jumps to the public IP. So router is a device which is capable of communicating between two different networks. So it allows the transfer of the packet from the intranet to the internet interface. Okay, and from here now it connects to the ISP, to the ISP service, and with the public IP, and with the public IP it reaches the Google's public IP. So private IPs are used for your internal connections, guys, or your local connections. So when packet needs to go from private IP3 to private IP1, it uses the, again, as I've mentioned, from your phone to your router, it uses the private IPs. From the router to the Google website, it uses the public IPs. So that's the main difference, where you use public IPs and where you use private IPs. Is that clear, guys? Any questions up to this part? What I mean by public IPs and what I mean by private IPs? Rohit, Shekhar, Brijesh, any questions?
Yeah, thank
Right. So now what I mean by that concept of NATing is, guys, now let's assume this is my home, Shoaib's home. Okay. Now somewhere over the internet you could have Brijesh's home as well. Okay, so let's say this huge box here is Brijesh's home. Okay. And in Brijesh's network as well, home as well, there could be a router, right? And to that router he could have his own personal devices again, okay, which are connected wirelessly. Okay, and they could get their private IPs as well, something like PR1, PR2, PR3, and PR4. Okay. Oh, actually, PR1 is usually given. The first private IP is always given to your router, actually. But let's assume, okay, this gets something like PR0 or something. Okay. Now, if you notice over here, these IPs are quite common. Okay. So what will be unique for each home will be the public IP, guys. So from the ISP, this guy will get another public IP. Let's say public IP2. IP2. And this is public IP1. So when my phone connects to a website like Google, and let's say when Brijesh's phone is also connecting to a website like Google, what happens here is now from PR1, let's say this is Brijesh's phone, the packet first comes to the router here, and from the router it goes with the public IP2 to google.com. So if you notice in my home, the private IPs are same, in Brijesh's home also private IPs are same. So you're capable of repeating private IPs multiple times, as many times as you want in different networks. What will be unique for each connection is the public IP. So my home will have public IP1 to connect to the internet. Brijesh's home will have public IP2 to connect to the internet. And when the public IPs expire, guys, then you have to go with a much more higher advanced range of IPs called IPv6 IPs. Okay. So till date, IPv4 have not expired. Public IPs have not expired. But one day, when the public IPs are all extinct and all expired, then we have to shift to or translate to IPv6. Okay. But for now, when my phone connects to google.com and Brijesh's phone connects to google.com, even though his phone and my phone have the same private IP in our local or individual networks, what will be unique to us is our public IPs. I will use public IP1 to connect to Google, and Brijesh will use public IP2 to connect to Google. And one day when all the public IPs are extinct or exhausted, then we go with a higher range called IPv6 addresses. Okay. But for now, I hope you have understood what this concept is. So that division of public and private IPs and repetition of private IPs is called network address translation. Okay. So yeah, any questions? If any questions, you can let me know. If not, we can conclude the session here, guys. And then next class, we'll talk about the ranges of public and private IPs. So these IPs have specific ranges defined by the people who invented IP addresses. We'll talk about those ranges in the next session in tomorrow's class. Okay. Yeah,
Sure.
Brijesh,
How would we know which IP address is public or which IP address is private?
yeah, as I've mentioned, Brijesh, we have a range for each of that. Okay, so in the next class, I'm going to talk about those ranges. So there's been certain specific ranges specified for each public and each private IP. As you can see, these are the private IP ranges specified by the people who invented IP addresses. Okay. So we have to remember these ranges. Okay. Shekhar, yeah, you were saying something.
Yeah. Shoaib, I have one question. You just explained that you mentioned that if all the IPv4 IPs are also exhausted, so that in that case we will be shifted to IPv6, right?
Mhm.
So
Yeah.
in today's scenario, our IPv6 are available because you mentioned in the starting that right now we are using IP version 4.
No. It doesn't mean that, again, as I've mentioned, when IPv4 IPs are exhausted, then if I want a new connection, let's say, in that scenario, I can't get an IPv4 anymore. I have to get an IPv6 compulsory. In today's world, the scenario is if you want, you can use IPv6 as well. They have already invented IPv6, and a lot of companies are already running on that advanced version, IPv6. Okay. They're not yet extant today. Okay, so they are not yet expired. But if you want, you can completely shift to IPv6 as well. Okay.
Okay, so today also IPv6 are available, right?
Yeah, we have IPv6. Some companies have been working on IPv6 since 2012 itself.
Okay,
So,
and maybe this is not relatable, but cryptocurrency bitcoins, all bitcoins are not mined yet. Only few of mine. So in terms of IPv4, all the IPv are in use, or few are like in use. What count?
but it doesn't have a link with IPs, right, Shekhar? So that
No, I'm
mining
just
happens.
I was just saying an example. My question is simple. 4.3 billion of total IPv4 we have in today scenario. So
Yeah.
all are in use today, or like only few, or
No,
half, or like
not all
some
have
percentage?
been. No, not all have been used. There are still IPs which are available, which have not yet been used for certain devices. So we still have IPv4 addresses available.
Okay, that was my
Okay.
question. Thank you.
Right. Any other questions, guys? Right. Assuming everything is clear. So I'm going to exit the session now, guys, and in tomorrow's class we'll continue exactly from where we left off. Okay. Before we do so, you can drop your email in the chat box, guys, and I can share this notes to you so that you can revise on it and go through it when time permits. So please drop your email addresses. I'll share this notepad file to you. Oh, hey Zain, can you hear me? Am I audible? You haven't been responding throughout the class. Mhm. Okay, did I add all the IPs or have I missed out something? Okay, I've got Bridgesh's IP, Rohit's IP, and Zain's IP. Okay. I guess Shekhar, I've not gotten your IP yet. I mean your email yet. Hello, Shekhar, are you there? No, Shekhar has gone offline. Okay, anyways, so yeah, that's that, guys. Nothing further for our class today. Tomorrow, we're gonna go with the remaining concepts. We'll learn what the classes of IPs are and what are the categories of public and private IPs. And then we'll also discuss some advanced concepts as well. What is DHCP protocol? What is DNS protocol? Okay, what are special IPs and so on. So, okay, so yeah, that's it, guys. Bye bye. Good night, and I'll see you.